Hello everyone and welcome to the next HSC Sim tutorial. In this tutorial we will learn to use the reaction unit operation model by creating a leaching process according to these specifications. We will start by creating the flow sheet and we will take the unit images directly from the unit icons tab and then select and resize, align, and okay, now we have the two reactors and then we rename them pulping tank and leaching reactor. Now if you take a unit icon from here, then it doesn't automatically have any kind of model inside. So we need to put this empty reaction unit operation model inside these units first. So I double click the unit, I go to the reactions tab and then select both of the units and double click this empty reactions unit. Now it puts the active model there and I press OK, and now when I double click, the model is there. Next we will create the streams, so we create the copper sulfide input and also the water input for the pulping tank. Then we transfer the slurry to the leaching reactor. We have some sulfuric acid input there. We have some air input. We have some gas out. Then we have the solution out, and then one stream for the energy. Then we will rename the streams copper sulfide stream, water, slurry to leaching, and then sulfuric acid, and then air, and then energy, and process gas, and solution out. Okay. Next we will start to define the actual unit operation models. So first, for the pulping tank, if I double click here, I have the input sheet which is empty, output sheet the same, distribution sheet where we distribute the phases to the output streams, control sheet, and then model sheet, which is the place for the actual unit operations, which in this case consists of reactions. Unlike the elemental distribution unit, the input and output sheets don't contain automatically anything. To make this unit work, we first need to define the variable list in the variable list editor. If I press here, I get the editor open. In here, I need to specify all the species in all the phases that I'm gonna use in my process. Not just in this unit, but for the whole process. I will also define all the variables here that I will use in the process. Now some of these variables, such as the density, volume, enthalpy for each phase, is automatically put here in the list. But I can also add some additional variables by using these tools over here. Let's start by adding the species of the process. So for the gas phase we have the oxygen, nitrogen. For the water phase we have the water, sulfuric acid, and then we have the ions such as copper, And in HSC, the ions are written with this kind of suffix where we have the charge and A after it. Then we have the sulfate ion, and then the hydrogen ion. Okay, and for the pure phase we have the copper sulfide and then some sulfur. After this we can check the measurement unit for each phase. So for pure and water phase, tons per hour is fine, but for the gas phase we might want to use the normal cubic meters, so we select it here, modify, and it comes here. Next, let's check the density calculations. So we have the density variables here, and the density is calculated automatically for each phase. However, for the water phase, by default the density calculations take into account only the water species. So if we want to take into account the effect of the other species and ions, we need to add that effect with the mass fractions, and we can press here and then add one by one. So for the sulfuric acid, we find the corresponding species in the database, sulfuric acid, we add that one. Then for the copper, so the copper ion, the corresponding species in the density database would be in this case copper sulfate, because we have the sulfate ion there, and we add that. And then for the hydrogen ion, the corresponding species would be in this case the sulfuric acid, and we add that. And now we have those variables here in the bottom, and now the effect of these species is taken into account in the density calculations with these. After that we also need the solid concentration, so we take the slurry and solid concentration grams per liter, we add that one, and we can see it here. We also need the energy variable because we have one energy stream in our system, so we add that one and we get it here. And finally we need to add the acid concentration for the variable list, and for that we don't have a ready tool here. However, we have this user formula tool which allows you to make a custom formula for the unit. So we will create custom formula for the acid concentration, we will add it, and now we get this custom formula row here, and we have this white cell here where we make the actual formula for this. And we want to take into account the effect of these, so we start by calculating the amounts of the hydrogen ion and sulfuric acid, and we divide by molar weight. And as everywhere else in HSC Sim, in all the Excels you can use these Excel calculation formulas that come with the sim, such as molar weight in this case, and then we have to divide it by 2 and then sum the hydrogen, the sulfuric acid amount divided by sulfuric acid, and then we multiply it by molar weight of the sulfuric acid to get the mass of the sulfuric acid, and then we divide that by the volume of the phase, and then we multiply by 1000 to get the unit, a measurement unit of 1 gram per liter. Okay, so now we have the custom formula there, and that should be ready. So now our variable list is ready. We press activate, And now the variable list is automatically put into every connected unit. So we have it of course in the pulping tank where we started to make it, but it is automatically also written here in the leaching tank. Okay, then we start to work with the actual process. So we have first the pulping unit operation where we make the slurry. So we had in the input sheet we write the inputs, so we write 10 tons according to the specifications of copper sulfide, and then we need some amount of water to make the solid concentration 250 grams per liter. We don't know it yet, so we just guess 1 ton of water. In the output sheet we don't need to do anything since we don't define here any amounts. In the list sheet we distribute the phases to the streams, and we have only one stream here, so we distribute all of these phases to the one stream. And now if I would calculate, I get some error in the leaching reactor because we haven't defined it yet. But if I go to the output sheet, I can see that everything that comes in, then it goes out. Now we will make the control to adjust the solid concentration, and we want it to be we have the measurement unit of grams per liter, and we want it to be 250. We get the measurement in the output in the solid concentration variable that we put there, and then we will adjust the water feed tons per hour, and we get the reference from the input sheet. We will set the limit a little bit higher and change the operation to the Newton-Raphson. Okay, the control was covered in more detail in the previous tutorial, so we won't go into too much detail in this tutorial. And now if we calculate, we get some results here. So with 37.78 tons of water we get the correct solid concentration now. As you can see, this value has been adjusted. Next we will define the leaching reactor unit operation, and if we take a look at the input sheet we can see that the input from the other unit is now coming here, and I cannot edit it here. And then we need to define how much air is needed and how much sulfuric acid is needed. And we also need to define the reactions that will happen in the leaching reactor. So let's start with the reactions. So we have a reaction for the sulfuric acid. And then we check the progress and press balance to balance this equation, and now it says OK, so this equation should be fine. Next we have the actual leaching reaction, which we will write here. So we have the copper sulfide, and we have the acid, and we also have the oxygen, and then on the other side we get the copper ion, and we get the sulfur, and we get the water. We balance, and we set the reaction progress. This wasn't mentioned in the specifications, so I will put some reasonable number, for example 90 here, and press activate. Okay, now if we check the model sheet, we can see that the reactions appear here. I can edit the progress rates here, or if I want to edit the reactions themselves, I just go back to the chemical reactions wizard and edit them here. In the model sheet we can also see some balance information of the unit. So now after we have made the reactions, we can see the balances for those reactions, how they affect the unit, and the input and output amounts. Now since we have the balance value for the oxygen, we can create the air feed for the system so that this will be satisfied. So we create the first, we refer to the balance sheet and multiply it by 1.1, and then we create the nitrogen amount so that the input feed becomes an air feed. So we just make some simple percentage calculations. Let's say that oxygen is 21 volume percentage, so we divide it by 21 multiplied by 0.79, and then we get the nitrogen amount. And now this value will always follow this value, which is always defined by this equation over here. Next we will set the acid concentration target, and we start by inserting some preliminary guess for the acid feed, 1 for example. Then we create a control for the acid concentration, and it is grams per liter. We want it to be 1, and we measure it with the output sheet, our custom formula for the solution out. And then we will adjust it with the acid feed, and it's tons per hour, and we get the reference here. And then we adjust the maximum, we change the operation, and now the acid feed should be set. Next we will make the dist sheet where we distribute the output phases to the output streams. So the gas phase goes to the process gas, and the water phase and the pure phase go to the solution out. Okay, let's calculate and let's see what kind of results we get. We see that okay, the control has reached the set point, and the acid feed has been adjusted accordingly. And in the output sheet we can see that the gas goes to the process gas, and then the water and pure phase go to the solution out as we defined. Now the final thing we need to add for the model is the heat balance. So we can see here that we have some different input and output enthalpy, and the balance is negative. So we will create the output energy feed by entering some value here for the energy stream, and then we will adjust it with the control. We measure it with kilowatts. We want it to be 0, and we measure it here in the model sheet, and we will adjust the energy out, and we get the reference from the output sheet here, and we increase the maximum, set the operation, and calculate, and then we get some results. So now if I go back to the model sheet, I can see that the heat balance is 0. And now our model is ready for this process so that it satisfies these requirements. Now we want to adjust something, like for example in the leaching reactor, the output temperature. we can go to the output sheet and then adjust the temperature to be 90, for example, and then calculate again. And the program calculates the new heat balance for the model. So now again we have the balance as 0 when the temperature of the leaching reactor is 90 degrees. This concludes the reactions unit operation tutorial. Thank you for watching.